everyone. Today in this video, as you can see the heading, it says pair of linear equations in two variables. First of all, let us understand what is the meaning of a pair of linear equations in two variables. First of all, what is a linear equation? A linear equation is an algebraic expression having equal to sign. Like we have here 3x is equals to 8 or 4y plus 5 equals to 3. So these are algebraic expressions which are having equal to sign. They are called as the algebraic equations. Now if you see the heading, it says pair of linear equations. That means we should have two equations and they should be in two variables. So I've taken some examples. Let's check which fits into this heading. If you see the first one, 3x is equals to 8. First of all, it's an equation, yes, but it has only one variable. So it's not a pair, it's not a linear equation in two variables. So not possible. Next, let's go to the next one. 4y plus 5 is equals to 3. Again, it's an equation, but again, it has only one variable, not two variables as per the heading. So again, it's not the required equation we are looking for. Let's go to the third equation. It's 2x minus y equals to 3. We have two variables, x and y. So yes, we got a linear equation in two variables. But then the heading says pair of two linear equations. That means I should have two equations in two variables. But here in the third equation third question, I have only one equation with two variables. So again, this is not the one which we are looking at. So at the end, can we see the fourth question? So fourth question has two equations. First of all, let's count. This is 1 and this is 2. So there are two equations. Are they both having two variables? Yes, x, y and xy. The third condition which is not mentioned in the heading is there should be two equations. Both of them should have two variables and these two variables should be same in both the equations. So thus, in this chapter or in this topic, we are going to discuss only about two equations having two equal variables or the same variables to be precise. Now, the general form of writing a pair of linear equations, that too in two variables, is a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. Here a1, a2, b1, b2, they are the coefficients of x and y. c1, c2 are the constant. And all these six terms or the six numbers will be real numbers. Again, the general form of the linear pair of equations will be a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals to 0. Now, these equations are represented by two variables. So, we can graph them. That means indirectly the linear pair of equations are representing lines. So, we have three conditions which we will looking at. If the pair of equations are represented by two parallel lines. So here I have the first equation, y equals to 2x plus 3 and y equals to 2x minus 4. They both are two equations having two similar variables, x and y. So these two equations represent lines and those lines are parallel. Okay. The second type of equation which will be represented by two intersecting lines. So here you can see y equals to 3 by 4x plus 5, which is the blue line, and y equals to minus 4 by 3x minus 6, which is the red line. Now clearly we can see here the two lines are meeting, means they are intersecting. So the linear equation are representing intersecting lines. So the second condition is they can be intersecting line. And the third condition or the third type that we have is the two lines can represent the same equation. That means the two equations are representing the same line and that they are called as coincident lines. Means we have two equations in two variables, but both the equations are representing the same line. So the three possible conditions you can say, or the three possibilities that we can have if we have two pairs of equations in two variables, is that the two equations are representing parallel lines, type 1. They are representing intersecting line, type 2. And they are intersecting coincident line. Now we are more focusing on finding the solution of these types of equations, means which represent intersecting line, parallel line and coincident line. So let's go through the conditions and understand if a particular equation is given or two equations are given, how to understand without solving how to tell whether the equations are going to be parallel, unique means intersecting, or coincident. So let's get into the condition, which is called as a condition for consistency. The condition of consistency tells us that without solving the equations, just with the condition, we can consider the condition rules and we can directly predict whether the lines are going to be intersecting lines, the equations are going to show intersecting line, or the equations are going to represent coincident line, or they are going to represent parallel lines. First of all, if you see, intersecting lines means the two equations will intersect and they will have only one solution. Means when we solve those equations, we'll come up with only one value of x and y, which is the point where the two lines are meeting, which is intersecting. If it is a coincident line, both the equations are representing the same line. And we know that in a line or on a line, we can find innumerous number of points because a line is made of infinitely many points. So every point on the line will be the solution. Next is parallel lines. Now we know that parallel lines never meet. Therefore, the equations will have no solution. Okay, so again, we're going into the condition without solving the equations. We'll try to find whether the equations represent an intersecting line, coincident line, or parallel line. Okay, first of all, if it is intersecting or a coincident line, we call it as consistent. Consistent means we can find the solution. That is why it is called consistent. Whereas parallel lines have no solution, therefore they are called as inconsistent. Okay. So let's get into the conditions. So the first one is condition for the lines to be intersecting line. Now as you can see, I have taken the general form of equation a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals 0. For intersecting line, the coefficient of x, that means a1 and a2, the ratio of the coefficient of x, a1 by a2, and the ratio of the coefficient of y, that is b1 by b2, they should not be equal. Then they are said to be consistent and they have unique solution. Same way, I have taken the same general form of the equation. Now, the condition for coincident line is the ratio of the coefficient of x, that is a1 by a2, the ratio of the coefficient of y, that is b1 by b2, and the constant, that is c1 by c2. All three ratios should be equal. Then again, it is consistent and infinitely many solution. Next, the third is parallel lines. Again, I've taken the same general form. Okay, the rule says that if the ratio of the coefficient of x, that is a1 by a2, is equal to the coefficient of ratios of y, that is b1 by b2, and that is not equal to the ratio of common constants, that is c1 by c2, then they are representing parallel lines. It's inconsistent, no solution, parallel lines. Again, let's go through it. If it is intersecting line, we call it as consistent. They have unique solution. And the condition is a1 by a2 is not equals to b1 by b2. If it is a coincident line, they will have infinitely many solutions and it is consistent. The ratios are a1 by a2, which is equal to b1 by b2 equals to c1 by c2. The condition says all the three ratios should be equal. If they are parallel lines, there is no solution. It's inconsistent. And the condition is the ratio of x coefficient, that is a1 by a2, is equal to the ratio of the y coefficients, that is b1 by b2. But they are not equal to the constant. So you need to remember these conditions. Now we are going to apply these rules and we are going to say that whether this particular equation, pair of equations given, is going to represent the intersecting line, coincident line, or parallel line. So let's take some questions. So as you can see the heading, it says find out whether the lines representing the following pair of linear equations intersect at one point, means intersecting line, they are parallel, means no solution, coincident means they are having infinitely many solutions. So first step for getting the condition is always shift the constant to the left. So rearrange this as 5x minus 4y plus 8, because we're shifting the 8 on the left, equals to 0. And the next equation 7x plus 6y minus 9 equals to 0. First we'll write out or we'll list out a1 a2 b1 b2. So a1 is 5, b1 is minus 4, c1 is 8. That is from the first equation. Then a2 is 7, coefficient of x in the second equation. b2 is 6 and c2 is negative 9. Again, what we are doing is we are just listing out the a1, a2, b1, b2 and c1, c2 from the given equation. Now we'll write the conditions. Means we are going to say this. a1 by a2. We are getting 5 by 7. Then b1 by b2. Which is going to be negative 4 by 6. We can simplify that and that will come out as negative 2 by 3. And c1 by c2 is 8 over negative 9. So clearly if you look at the ratios we have is 5 by 7, minus 2 by 3 and 8 by negative 9. So can we say here a1 by a2 is not equal to b1 by b2? So it is intersecting at one point. That's the answer. Okay, let's take the next question. Okay, the next question is 9x plus 3y minus 12. So let's shift it again and rewrite it. So I'm going to write it on the left here. 9x plus 3y plus 12 equals to 0. 18x plus 6y plus 24 equals to 0. Let's list out. So a1 is 9, b1 is 3, c1 is 12. a2 is 18, b2 is 6 again, and c2 is 24. I'm sorry. So first let us put the ratios and find out whether they are equal or not, and then we'll come to the condition. So we'll say a1 by a2 is 9 by 18, which can be simplified as 1 by 2. b1 by b2 is 3 by 6, again simplified as 1 by 2. c1 by c2 is 12 by 24, again 1 by 2. So all the three ratios are equal. So if all the three ratios are equal means a1 by a2 equals to b1 by b2 equals to c1 by c2. That is coincident line. Okay, next take the next one. 6x minus 3y plus 10, 2x minus y plus 9. Now we don't have to rewrite it here because it's already the constants are on the left. So we'll just directly say a1 is 6, b1 is minus 3, c1 is 10. Then a2 is 2, sorry, b2 is minus 1 and c2 is 9. So let's write the ratios. So a1 by a2 is 6 by 2, which gets simplified as 3, right? Then b1 by b2, which is negative 3 over negative 1, which is again 3. Let's write the next ratio, c1 by c2, which is 10 over 9. Now clearly a1 by a2 is 3, b1 by b2 is 3, but c1 by c2 is 10 by 9. So we can say that here a1 by a2, the ratio of x coefficient is equal to the ratio of the y, but not equals to c1 by c2. So they represent parallel lines. Again, the rule is if a1 by a2 is not equals to b1 by b2, intersecting at one point. a1 by a2 equals to b1 by b2 equals to c1 by c2, coincident line. a1 by a2 equal to b1 by b2 is not equals to c1 by c2, parallel lines. So I've taken some questions for you to solve as extra practice. Please go through it.